Building on our knowledge of data structures and I/O operations, we're now entering the world of object-oriented programming. OOP is a programming paradigm that helps us organize code into reusable, structured components called objects. This approach is particularly powerful for modeling real-world concepts and creating maintainable, scalable applications. Today's lesson builds on our previous Python knowledge while introducing a new way of thinking about code organization. OOP is not just about syntax, it's about design philosophy. We'll learn how to structure our code in a way that reflects real-world relationships and promotes code reuse. Understanding these concepts is crucial for building larger, maintainable applications. OOP is a programming paradigm that organizes code into objects, which are instances of classes. Think of a class as a blueprint and objects as the things built from that blueprint. This approach helps us model real-world relationships in our code. The core concepts, inheritance, encapsulation, polymorphism, work together to create maintainable and flexible code structures. This is our first class definition. The __init___ method is the constructor. It's called when creating a new object. Self refers to the instance being created. Methods are functions that belong to a class. Notice how we combine data, name, age, with behavior, bark method. Each instance of the class has its own set of attributes but shares the same methods. Class variables are shared among all instances of a class, while instance variables are unique to each instance. Class variables are defined directly in the class body, while instance variables are typically defined in __init__. Be careful with mutable class variables as they can lead to unexpected behavior when modified. Understanding this distinction is crucial for proper OOP design. Instance methods are functions that belong to a class and can access/modify instance attributes. They always take self as their first parameter. Self refers to the instance that called the method. Methods can take additional parameters and return values. They define the behavior of our objects. Python supports different types of methods. Class methods receive the class as their first argument, CLS, and can create instances in different ways. Static methods don't receive any implicit first argument and are basically utility functions. The @class method and @static method decorators tell Python how to handle these methods. Each type has its specific use cases. Inheritance is a core OOP concept that allows us to create a hierarchy of classes. The parent class, animal, defines common attributes and methods, while child classes, dog, cat, inherit and can override these. This promotes code reuse and represents is-a relationships. Notice how each child class provides its own implementation of the speak method. The super function is used to call methods from the parent class. This is particularly important in __init___ methods to ensure proper initialization. Notice how electric car extends the basic vehicle functionality while adding its own attributes and overriding methods. This demonstrates how inheritance can be used to specialize behavior while maintaining a common interface. Multiple inheritance allows a class to inherit from multiple parent classes. This can be powerful but should be used carefully to avoid complexity. Python uses the method resolution order, MRO, to determine which method to call when names conflict. Mix-ins are a common use case for multiple inheritance, where classes provide additional functionality that can be mixed in to other classes. Abstract base classes, ABC, define a common interface that derived classes must implement. Abstract methods must be implemented by any concrete, non-abstract, child class. This enforces a contract that all shapes must have area and perimeter calculations. ABCs are useful for ensuring consistent interfaces across related classes. Properties provide a way to control access to class attributes. The @property decorator creates a getter, while @attr.setter creates a setter. This allows us to add validation and computation while maintaining a clean interface. The underscore prefix, _balance, is a convention indicating the attribute is intended for internal use. This is how Python implements encapsulation. Composition is an alternative to inheritance where objects are built by containing other objects. This follows the has a relationship rather than is a. Composition often provides more flexibility than inheritance and helps avoid some of the complexities of inheritance hierarchies. It's a fundamental technique for building complex objects from simpler ones. Method resolution order determines the sequence in which Python searches for methods in the inheritance hierarchy. Understanding MRO is crucial when working with multiple inheritance. Python uses the C3 linearization algorithm to determine MRO. You can inspect a class's MRO using the _MRO_MRO__ attribute or the MRO method. Magic methods, Dunder methods, customize how objects behave with built-in operations. __str _ defines string representation, __add__ enables the plus operator, __len__ allows len function use, and __eq__ defines equality comparison. These methods make our classes behave like built-in types. Understanding magic methods is key to creating intuitive class interfaces. Context managers provide a clean way to handle resource acquisition and release. The __enter__ method sets up the context, while __exit__ handles cleanup. This pattern is perfect for managing resources like file handles, network connections, or database connections. The with statement ensures proper cleanup even if exceptions occur. Follow the single responsibility principle. Each class should have one primary responsibility. Prefer composition over inheritance when possible, it's often more flexible and maintainable. Use clear, descriptive names for classes and methods. Keep inheritance hierarchies shallow. Document your classes and methods. Consider using data classes for data-focused classes. We've covered the fundamental concepts of OOP in Python. Understanding these concepts allows you to create well-structured, maintainable code. Remember that OOP is not just about syntax, it's about designing your code to model real-world relationships effectively. Practice these concepts by refactoring existing code and designing new systems using OOP principles.